There are three laws on the topic of thermodynamics. The first law says that energy cannot be created or destroyed in a chemical reaction. The law conservation of energy states that energy can neither be created nor destroyed and can only be transferred or changed from one form to another. This is like turning on the light bulb to your bedroom. Light is electrical energy that is converted to the light. The law states that there are two kinds of processes that can lead to a change in the internal energy of a system. If heat flows into a system or the surroundings to do work on it, the internal energy increases. If heat flows out of the system, work done by the system will be at the expense of internal energy and will become negative. The second law states that the entropy of any isolated system not in thermal equilibrium will almost always increase. Entropy is a measure of disorderness. If you have a bowl full of Skittles and it dumps all over the floor, the disorderness increases. Think about when you get yelled at for having a messy bedroom. If it starts off very clean and you go upstairs to play with your toys and you don't put them away, it starts to get messy again. Because you left your toys out and you threw your shoes in the corner or didn't pick up your clothes, the disorderness increases, as does the entropy. The third law of thermodynamics states that the entropy of a system approaches a constant value as the temperature approaches absolute zero. Absolute zero is the lowest temperature possible and is not physically possible as it is 0 degrees Kelvin. For a perfect crystal, this is a constant zero. In a perfect crystal, every molecule is the same and aligned perfectly. Water is an example of the third law. Water vapor has a high entropy because it has so many molecules in a random order. The gas cools down and becomes liquid water, which has become a greater structure than gas. The water cools down even more and becomes an ice cube on a table. As the water is cooling down, the motion and randomness goes down, so at absolute zero there is no movement at all. Gibbs is the amount of free energy in a chemical reaction that can be captured, stored, and used to do work. During the reaction, there will be a change in energy between reactants and products. Spontaneous energy is a natural process reaction that proceeds in a definite direction on its own. When a large number of individual interactions are involved, then the direction will always be in the direction of increased entropy. This is very similar to pushing your toy car or ball down the big hill at the park. When the ball is pushed, it continues to go in that direction until it reaches the end of the hill. Non-spontaneous energy requires energy to be contributed in order to start the reaction or the use of outside help. Unlike pushing the ball down the hill and not having to do anything besides push it over the edge, you'll have to push the ball really hard to make it go up that big hill. Gibbs free energy is essentially the amount of energy that is released in order to accomplish something. The answer is a measurement of free energy called Gibbs free energy. The change in energy, change in G, in a reaction can be calculated using the following equation. G equals change in H minus T change in S. Change in S is the amount of energy lost to entropy. Change in H is the total energy change in the system. T is the absolute temperature in Kelvin. Activation energy typically comes from the heat energy of the system's surroundings. Your favorite toy truck, Tow Mater, has been sitting outside for a very long time. Because of the activation energy, it causes the toy to start to rust, creating troubles when you play. ATP is a wrapped up present. It is only useful when opened. The content, in this case energy, remains potential until broken apart. A hydrolysis reaction is the child's hand unwrapping the gift. Water breaks down ATP and goes to ADP. Released energy is used by the cells as heat or stored up for a later time. Phosphorylation is a phosphite ion that is lost one reaction and then added to another compound of ADP to recreate ATP. It is also used as a fuel for chemical reactions in a process known as energy coupling. Metabolic disequilibrium is a defining feature of life. If the body achieves equilibrium, then you are dead. When a reaction is towards equilibrium, the amount of free energy decreases, or if it is not near equilibrium, the amount of free energy increases. A person starts off with ADP. The energy source is then added, in our case, food. The energy source then adds a phosphate and turns ADP into ATP triphosphate. ATP then powers the cells in the system. Eventually, ATP turns back into ADP in a full cycle. It's kind of like a battery. It starts off uncharged and then energy is added to it, charging it. Once it's charged, it's ATP. When it loses its charge, it transfers back to ADP or an uncharged battery. That concludes our lesson on thermodynamics. Thanks for listening.